Hi, welcome to Provoke Your Physics channel. The last class how the dielectric was affected or increased the capacitance of the capacitor அப்படிங்கிறத பார்த்தோம். இப்போ என்ன பார்க்க போறோம் அப்படின்னா how the dielectrics are connected in series and parallel. Okay, how the net capacitance will be affected அப்படிங்கிறத பத்தி பார்ப்போம். அதுக்கு முன்னாடி how the capacitance will be varied when it is connected in series and parallel. இதை பாருங்க. So when the capacitors are connected in series, okay, the net capacitance 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3 etc. அப்படின்னு சொல்லி சொல்லுவோம். அதே மாதிரி when the capacitors are connected in parallel, Cp is equal to C1 plus C2 plus C3 அப்படின்னு சொல்லி சொல்லுவாங்க. Okay. இப்போ நான் என்ன எடுத்துக்க போறேன்? So when the capacitors are connected, okay, with three different dielectrics in this format. Okay, so each one having the thickness d by 3, having the area a அப்படின்னு வச்சுக்குவோம். Okay, அதே மாதிரி இன்னொரு ஆப்ஷன் என்ன அப்படின்னா when the capacitors are connected with இந்த இதுல எப்படி இருக்கு அப்படின்னா how it is being connected. See, in this way. Okay, so how the capacitors will be vary its value adha paapom. Okay, fine. See, look at this example. This example can be treated as the capacitors will be connected in series form, but this can be treated as a parallel form. Okay, so we are going to use this formula, okay, to solve this. How? Let us see. First, let me take this one. Okay, this example. Actually, here there are three dielectrics K1, K2, K3. Okay, and these three can be treated as a series connection. Okay, so I know that the C is equal to epsilon naught A divided by D. And especially when it is air, C naught. Suppose if it is a medium, C will be equal to K times epsilon naught A divided by D, where K is the dielectric constant. We have already seen that. Okay. See, in this case, okay, having a thickness D by 3, having a area A. So let us take C1 will be equal to, okay, K1 times epsilon naught A divided by D by 3. That means 3 times of this 3 will go up. K1 times epsilon naught A divided. Okay, similarly C2 is equal to 3 times of K2 epsilon naught A by D, and C3 will be equal to 3 times of K3 epsilon naught A by D. Now, when these three are connected in series, I know that 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So, when I substitute this value, okay, so I know that instead of C1, I am going to write K1 times epsilon naught A divided by D. See here, epsilon naught A divided by D will be the constant. Let us take. But remember, it is a denominator or reciprocal. So, I will take, okay, 3 times of K1 into epsilon naught A. So D will go up, D. Okay, plus D by 3 times of K2 epsilon naught A plus D by 3 times of K3 epsilon naught A. See, in this term, if I have taken D by epsilon naught A into 3 as a common term, okay, that is D divided by 3 times of epsilon naught A, okay, into 1 by K1 plus 1 by K2 plus 1 by K3. Okay, so this is the answer for when the capacitors having a 3 different dielectric was inserted in this condition. Okay, in this condition, it will be treated as a series combination. Now, for the parallel combination. See, this is a thickness and having the area A by 3, A by 3, A by 3. Okay. So in this case, okay, it will be treated as a parallel combination. So now for the parallel combination, okay, so of course C is equal to K times of epsilon naught A by D, but here A is equal to A by 3. When I substitute A is equal to A by 3 and D does not change, so I will get C1 will be equal to K1 times epsilon naught A by 3 divided by D. That will be equal to, okay, times divided by 3 into epsilon naught A by D. Similarly, C2 is equal to K2 by 3 into epsilon naught A by D, and C3 will be equal to K3 times by 3 into epsilon naught A by D. So, for the parallel, CP will be equal to C1 plus C2 plus C3. Okay, so when I substitute the value here, so which are all the common term? Epsilon naught A by D divided by 3. Okay, so let me take epsilon naught A divided by 3D, okay, into K1 plus K2 plus K3. Okay, so here we come to know one thing: when the capacitors are connected in series, okay, its value will be reduced. When the capacitors are connected in parallel, its value will be increased. The first thing. Second thing, this will be same even when the dielectric is introduced. When the dielectric is introduced, definitely the net capacitance is going to be increased. But when it is a series combination, okay, how it is being affected? When the parallel combination, how it is being affected? That is very, very important thing. Thank you. If you like this video, please share, subscribe and like.